Hello, I am here to talk about our research paper on searching for fine-grained queries in radiology reports using similarity-preserving contrastive embedding. This is joint work with Leo Shi from the Amaden Research Lab of IBM. As you all know, electronic health records routinely capture textual reports coming from a variety of sources such as discharge summaries, radiology, cardiology reports, lab reports, etc. Now, if these reports could be searched, they could reveal valuable information about the patient's condition, which could be used for many downstream purposes, such as in clinical decision support or selecting patients, relevant patients for clinical trials, or for doing population health studies. Recently, they've also been used for auto labeling of image data sets from radiology reports to build machine learning models. Now, using simple techniques such as TF-IDF, which is very popular in the document retrieval domain, doesn't work very well for such reports as they fail to capture domain semantics. Let's take an example. If you had a query such as right upper lobe pneumonia, you can see the kind of matches that would be produced by a document retrieval approach. You can see that negations are missed, location and lateralities may also be missed, and the match to the core concept, which in this case is pneumonia, should itself may be missing. Similar observations can be made with more modern neuronal approaches, such as the transformer based models, even using those that are trained on clinical vocabulary, such as clinical BERT. And here you can see an example with for the same query with using clinical BERT as well. So, our approach essentially addresses that problem. It says how one could, first of all, capture the clinical domain semantics by doing a natural language understanding of the sentence through phrasal grouping and extracting fine grained finding patterns that capture the key clinical concept, which in this case was a finding, and then associates relevant modifiers with those findings, such as their laterality, location, and so on, and can also look at both positive and negative occurrences of such findings. We encode these patterns using a new similarity preserving contrastively learned textual embedding that captures the domain semantics as provided through a clinical lexicon, in this case, a chest x ray lexicon. Using these FFL pattern encodings, we can now reverse index the documents and reports and use a ranking algorithm to filter the matches, and the eventual filtering can be further enhanced using BERT on FFL patterns. This results in about 33% improvements in mean average precision. Come see our poster for more details on how this method works and how this could be utilized for improving searches of electronic health records in textual reports.